This is the famous problem of the stack of three smooth cylinders on a smooth horizontal floor acted by a horizontal force F. We have to find out the range of this horizontal force so that these three cylinders will remain in contact. First, we will consider the case when the horizontal force is absent. Look at this figure. At the absence of this horizontal force, the reaction forces on this upper cylinder from these two cylinders will be of same magnitude, and due to this reaction force of same magnitude of R will be acted on this cylinder along this direction, and as initially these two cylinders are in contact, reaction force from this right cylinder to this left one will be R prime. Due to these two forces, that is R prime and R, this left cylinder will move leftward, and as a result the system will collapse. So to make this system stable, we have to apply a horizontal force F. We have to find out the range of this horizontal force so that these three cylinders will remain in contact. Now, what will happen if we gradually increase this force from the value 0? If we increase this force, then a moment will come when this when this contact is on the verge of detachment. That is, we just balance this tendency of detachment. At that moment, there will be no contact at this point, so the reaction force between these two cylinders will be absent. And then what will happen to these reaction forces? Actually, these two reaction forces then will not be of same magnitude. Question arises, why? Actually, when we apply a force F, this system will have a tendency of moving rightward with acceleration f by 3m. So pseudo force, this is a pseudo force, will act on this upper cylinder. This pseudo force has a component along this direction, upward direction, which will make this reaction force lesser than R, and the component of this pseudo force along this direction will make this reaction force greater than R. So as a result, these two reaction forces will not be of same magnitude. Obviously R1 would be greater than R2. Now we will consider the moment when these two cylinders are on the verge of detachment. At that moment, the forces on the upper cylinders would be R1, R2 and its own weight, and the forces on these lower cylinders would be R1, the weight downward, weight of its own weight which acts downward, the normal reaction force N by this floor, and the force F which acts rightward. For this upper cylinder, as R1 is greater than R2, the horizontal components of these two forces will make this upper cylinder moving along this direction. So we can write the equation of motion of these cylinders as R1 minus R2 sine 30 is equal to m into a, that is m into f by 3m. And the equilibrium along the vertical has the form R1 cos 30 plus R2 cos 30 is equal to W, that is mg. So R1 plus R2 is equal to 2 mg by root 3, and r1 minus r2 is equal to 2f by 3. Now consider the motion of this lower one, the horizontal motion. We can write f minus component of r1 along this direction, that is r1 cos 60, f minus r1 cos 60, which will make this cylinder moving rightward with the common acceleration a. So we can write f minus r1 cos 60 is equal to ma, but ma is nothing but m into f by 3m, f by 3. So we readily get f is equal to r1 is equal to 4f by 3 from this equation, and here r1 minus r2 2f by 3. So just put r1 here, then we get r2 is equal to 2f by 3. So r1 plus r2 would be, just add these two terms, 6f by 3, but r1 plus r2 is 2mg by root 3. So we get f is equal to mg by root 3. This is the minimum force for which this system remains in contact. What will happen if we increase this force further? If we increase this force further, this pseudo force will also increase, and as a result, this pseudo force will make this contact detached. At that moment, this reaction force R2 will be absent. So just put in this reaction, this equation and this equation, R2 is equal to 0. We get R1 is equal to 2mg by root 3 and R1 is equal to 2f by 3. So R1 is equal to 2mg by root 3 is equal to 2f by 3. We just have put R2 is equal to 0. We readily get the maximum force root 3 mg. Thanks.